Hello guys, in this video, we are going to build a machine learning system that can predict whether a person has a diabetes or not. We will be using one of the important machine learning algorithm, that is support vector machine. We will do our coding in Python. First, we try to understand what is our problem statement and something about SVM, that is support vector machine. So SVM model or is a supervised learning algorithm. In supervised learning algorithm, we feed data to our machine learning model, and machine learning model learn from the data and its respective levels. So the levels are the most important things. In this case, we train our model with several medical information such as blood glucose level, insulin level of the patient, along with whether the person has diabetes or not. So this act as a level whether that the person is diabetic or non-diabetic. So this will be the level for this case. Once we feed this data to our SVM model, it tries to plot the data in a graph. Once it's plot the data, it tries to find out a hyperplane. So in this image, you can see a hyperplane. The hyperplane separates these two data. So once we feed a new data to this model, it tries to put that particular data in either of these two groups. So one in this group and one in this group. And by that, it can predict whether a person will be diabetic or non-diabetic. So in this case, we use several medical information such as BMI of the patient, their blood glucose level, their insulin level, etc. So now let's try to understand the workflow of the project. So first we need this diabetes data. We will try to train our model with the data and the respective levels. Before feeding this to our model, there are a lot of steps in between. So we need to pre-process the data where we will try to analyze the data, and this data won't be very suitable to feed to the machine learning model. So we need to standardize the data because there are a lot of attributes here. A lot of medical information are there. So we want all this data to be in a same bridge. So we try to standardize all this data so that all this data lies in the same range. So all these things will be done in data pre-processing step. So once we pre-process the data, we will split the data into training and testing data. So we train our model with the training data, and we try to find the accuracy score of our model with the help of try to find our accuracy score of our model with the help of test data. It will tell how well our model is performing. Once we split the data into training and testing, we will feed this to our support vector machine model. We will be using a classifier model where this model will classify whether the patient has diabetes or not. Once we train, we have a trained SVM classifier or support vector machine classifier. So when we give a new data, it can now predict whether the patient is diabetic or not. When we give this new data to the trained support vector machine classifier, it will predict whether the patient is diabetic or non-diabetic. So this is the workflow we will be following for this project. So let's start with the coding part. So we will start coding in Google Collaboratory. So you just search for this collab.research.google.com and this page will appear. Click on File, open New Notebook. So click on connect. So it's connected. So we will name this file as diabetes prediction. So let's start to import the dependency. So import numpy s and p, import pandas spd from sklearn pre-processing, import standard scalar standard from sklearn dot model selection, import train test split from sklearn, import SVM from sklearn dot matrix, import accuracy score. So we will, and these are the dependency we will try to import. So and numpy is used to make numpy arrays, and pandas as PD is used for creating data frames. It is also used to put data in nice structured table format. So what is this standard scalar? This is used to standardize the data to a common range. So train test plate is used to split the data in training and test data. So this SVM is the model that is support vector machine model, where we will train our data by using which by using this model we will train our data. So it's the evaluation matrix, the accuracy score, where model evaluation will be done. So we will run this, shift enter. So all our dependency is loaded. So now let's see our data set first. So you can see the data set. It's there are 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So where eight column are the feature column, and outcome is our level column, which predicts whether the patient is diabetic or not. So this data is a PIMA diabetes data set, which is also present in UCI machine learning repository and Kaggle. It contains data for females. It contains various parameters such as number of pregnancy they have gone through, their blood glucose level, insulin level, BMI, and age. And so basically it's only a female data set. So we will close this. So now we will load this data set into our data frame. So for that, we have to upload the data set in this. So click on this folder option and right click and upload. So diabetes. So just copy this path. So that we will start loading the diabetes dataset to pandas data frame. Equal to pd dot so pd dot read csv, and we will paste that path copied from previous one. So we will paste it here. So our data set is loaded into a pandas data frame. So let's check the first 5 rows of the data set. Dot head. So you can see the first 5 rows of the data set, which contain the pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, age, and outcome. So what is this skin thickness? Skin thickness is taken from the tricep. Basically, it tells whether some fat is stored in that particular muscle. So insulin, BMI, diabetes, pedigree, function, it's a number which indicates some diabetic value. So, and this BMI is generally calculated by dividing the weight by the height squared. So this is the output column. 1 indicates the diabetic and 0 indicates non-diabetic. So we will proceed with our coding part. So now we will find how many number of rows and columns are there in the data set. So diabetes dot shape. So you can see that there are 768 examples or peoples, and there are 9 columns, where out of which there are 8 feature column and 1 is a label column. The outcome is the label is our label column. So we will do some statistical method on the data set. Diabetes dot So these are some of the characteristics of this data set. So you can see the count, the mean, the standard deviation, the minimum, the 25% of the data, that is the 25 percentile of the data, that is 25 percentile of this data of pregnancy data is less than 1. So let's count the how many examples are there for diabetic patient and non-diabetic patient. So diabetes outcome dot value underscore counts. outcome dot value diabetes data set. Outcome value dot count. Okay, there is an extra port over here. So you can see that there are 500 non-diabetic and 268 diabetic patient. So this is a smaller data set. Typically in machine learning, we will be using like thousands or lakhs of data set to get a perfect, more perfect model. So we will just see how the system works. So we are taking this smaller model. So let's proceed. So again, we will get the mean of every row. So is data set dot group by. So basically, this group by outcome dot mean will gives mean value for both the cases. So you can see that for a non-diabetic patient, the value are less, and for diabetic patient, the value are less, value are more. So you can see the glucose level is more for a diabetic patient, and for non-diabetic patient, it is less. All the values are have a very much difference in them, which will help us to predict whether the person is diabetic or not. So let's start separating the data and labels. Draw. So if you are dropping a column, then axis will be 0. Otherwise, if you are dropping a row, if you are dropping a column, then axis will be 1. And if you are dropping a row, then axis will be 0. So here we are separating all the features value in X, and all the label value in Y. That is the outcome value in Y. So we have, let's see our X and Y value. This is the X value, that is the feature column values. And let's see the Y value, which contain nothing but the outcome value. So you can see the 1 0 1 0 1. So now what will we do is we will do a standardization on the data. So why data standardization is done? So why we are doing this? You can see we have number of we can see that we have number of pregnancy, glucose value, blood pressure value, BMI, etc. The range is something for pregnancies like 1 2 or 3. Glucose is something around 100 to 150. Blood pressure is something around 60 to 70, and BMI is something around 25 to 30. If there is a difference in the range for all this value, it will be difficult for our machine learning model to make some prediction. So in most cases, what we will do is we will try to standardize the data in particular range. It helps machine learning model to make better prediction. So for that, we are doing standardization. So let's see how it is done. So we will do scalar equal to standard scalar. So we have imported a standard scalar previously from sklearn library. So we will run this. So scalar dot fit, and we will pass our x value, which is nothing but the features value of the data set. So our standard scaling is done. So we are fitting all inconsistent data with standard scalar function based on standardization. Then we have to transform that standard scalar standardized data so that all the data will be in a common range. So let's transform it. Standardized data is equal to scalar dot transform. We'll pass the value of x here. So our standardization is completely finished. So we will print that standardized data. So let's see how our standardized data look like. So you can see the value has been decreased. So the ranges have been decreased, like something around like -1 to 1 kind of. Previously, we are having ranges, very high ranges. So all the values are within a fixed range. So it helps our machine learning model for better prediction. So we will separate this standardized data into our label and call into a feature and label variable. So again, x is equal to y equal to to print the value of x and y. So shift enter. So we can see the value of x and the value of y, the standardized values. So we will proceed for training, testing, and splitting. So train x underscore test y underscore train and y underscore test equal to train underscore test split x y, give the test size equal to 0.2 then stratify is equal to y random underscore state equal to 2. So what basically this sentence means that we are keeping the training data in xtrain and training label training feature in xtrain and training label in ytrain and a testing label in testing feature in xtest and testing label in ytest. So we will split the data set and our test size will be 0.2. That is means 20% of the data is will be used for testing purposes and remaining 80% will be used for the training purposes. So stratify equal to y. This we want the data set to be splitted in the same proportion. So for that purpose, we are using the value y, because if we don't mention this, and there is a chance that all the cases for diabetic will go to one data frame. So random set equal to 2. So for this, basically, we can give any value here, but to match my result with your result, so we will give a fixed random set here. So we will run this test underscore size. So the model we have then print. So now we can see the data set after splitting. So this is our original data set 768 and 8 8 features column, and that is divided into 614 and 154. So with 80-20 rule. So let's now start training our model. Classifier equal to SVM dot SVC kernel equal to linear. So basically, it's a support vector. SVC is a support vector machine classifier, and the model which we are using is linear model. So now the training, we will train our support vector machine classifier. Classifier.fit. Classifier is not defined. So we'll use the same name as used here. So now our model is trained and fit. So now we will see our accuracy score on training data. So X underscore train prediction equal to classifier dot predict X train training data data underscore accuracy we will use the accuracy score to X train. Use this train underscore prediction comma Y train. We will run this. So now we will print our accuracy score for the training data. So print accuracy score of the training data pass the training data accuracy. So let's see what's our accuracy score for training data. So it's coming around 78%. So similar case will be followed for the testing purposes, testing data. So we will copy this and we will check what is the accuracy of the testing data. So as state text. Test data accuracy X test and Y test. So enter. And we will print that accuracy score of the test data also. So here we can see that the accuracy of the test data is coming around 77%. So generally our training accuracy is more than the testing accuracy. So it is considered to be a good model. That the model has not overtrained. Overtraining represent the model just trains a lot of training data that it cannot perform well on the test data. So in that case of the training data, accuracy will be very high and the test data accuracy will be very low. So this concept is known as overfitting. So here we are getting a decent model. So our model is performing well. So we will now develop a predictive system giving a raw data input. So let's start making a predictive system. So input and it's got data. So we will take one data. We'll open this in Notepad format. So let's take this value. So here outcome is non-diabetic. So let's copy it and paste it. We will not include the outcome column as we are predicting the outcome column and checking whether our model is working fine or not. So we will remove that. So now we will change the input data to a NumPy array. So input underscore data as numpy array as array input data. So now we have to reshape the array as we are predicting for one instance. So input data underscore reshaped equal to reshape as we are using this for one instance, so we have to write the reshape as 1 minus 1. So previously we have standardized our data set. So the model is being developed with that standard data. So for this instance also we have to standardize the data before giving the input to that out to our model. So std underscore data scalar dot transform. So previously what we are doing is we were standardizing it and then transforming it. We were standardizing the model first, and then that's standardized data we will transform it and store in the standardized data format. So we can do that in one single step. So std data equal to scalar dot transform, and we will give the input data, our reshaped data. So we will print this standard data. So now we will print a prediction also. We will do the prediction classify.predict, classify contain the SVM model in our trained model, SVM trained model. So print prediction. So how we will know that the person is diabetic or not? We will just write a if condition. If it's 0, then print the person is not diabetic, else print the person is diabetic. So now we will run this command. So invalid syntax. So we are missing this colon. Yep. Import can name be okay. So this is the warning, we can ignore that. So here you can see that a person is non-diabetic, and our model also says that a person is was non-diabetic. So we have successfully trained that model. So that's all from my side. Hope you enjoyed this video. Thank you.